In this video, we're going to wrap up our coverage of rigid transformations in the Cartesian plane by talking about the third of the rigid transformations, which are rotations. So we've talked about translations and reflections already. When we do rotations, remember we need to specify a couple of things when we describe the rotation we want. We need to describe the angle we want to rotate by. We also need to talk about whether we're going clockwise or counterclockwise most of the time. And remember, the third thing is we need to talk about what the center point of our rotation is. For this class, the only rotations we're going to do are going to be rotations around the origin. If you need to do rotations around other points, it's a little bit more complicated. It's not something we need to get into in this class. If you go to college and become like a graphic artist or something like that, or somebody who programs video games, you will definitely study rotations around other points in far more detail, but we don't need to get into that this year. So we will stick ourselves completely with rotations around the origin. Let's go back to GeoGebra and get an introduction to how this looks. So here's our triangle again. And this time we're going to rotate the triangle around the origin. And I want to start off by going 90 degrees clockwise. Excuse me, I want to go 90 degrees counterclockwise. So remember, counterclockwise is the opposite of the way that a clock hand moves. So it's going in this order, the order that my cursor is going around. So what quadrant will the image of this triangle be in when we do a 90-degree counterclockwise rotation? It will be in 90 degrees counterclockwise, and our image will be in the second quadrant. Okay. Now let's talk about a 90-degree clockwise rotation of this original triangle. Okay, so rotate around a point. There's our figure. There's our point. And I want to choose 90 degrees clockwise. And the image for this is going to be in the fourth quadrant. And the last thing is, let's talk about a 180-degree rotation. And with 180 degrees, we don't really need to talk about whether we're going clockwise or counterclockwise, because it's just going halfway across the circle. It would be the same destination whether we go around in a counterclockwise or a clockwise order. And if we spin it halfway around the circle, it will wind up there in the third quadrant. Okay, so what I want to do is I want to do the same activity we did for the reflections. So I've got a sheet here which shows the coordinates of our original point here in the first quadrant. So A, B, and C, the coordinates of that. And A prime is going to be the image after we do a 90-degree counterclockwise rotation. A double prime, B double prime, C double prime are the coordinates when we do a 90-degree clockwise rotation. And A triple prime, B triple prime, and C triple prime are the coordinates when we do a 180-degree rotation. So copy down this sheet on a scrap piece of paper, and then we'll go back to GeoGebra and find the coordinates of the image points from the three different rotations and see if you can calculate the rule based on that for what the three rotations are going to look like. Okay, so as you're doing that, I am going to do it myself. And this one is all right. So welcome back. And so here is the sheet that I came up with for the coordinates of the points under these three different rotations. And so based on that, what do you think our rule is going to be for these three things? Well, one thing that was interesting about these is that notice how, for instance, in this first translation, we went from 2 comma 6. The coordinates, first of all, they swapped places. So the x coordinate became the y coordinate became the x coordinate, but then it changed signs because it was in the second quadrant. All right. So how do you think we're going to write that using this notation? Well, our x coordinate, the x coordinate in the input, became the y coordinate of the output. So I'm going to put x over here. And what is the x coordinate of the output? Well, the x coordinate of the output is going to be negative y. All right, so here's how we write that. So if we want to find a 90 degrees clockwise rotation and we just have the coordinates of the original point, to figure that out, to figure out the coordinates of the image, we're going to swap the two coordinates and then switch the sign of our new x value. All right, so now that you've seen that example, if you haven't come up with rules for the other two, why don't you pause the video and see if you can come up with them now. So for a 90-degree clockwise notation, we see that we're doing the same basic things. We're swapping the coordinates, but this time it's the second quadrant. It's the y coordinate where we're swapping the sign. So we're going to write that as y comma negative x. It's the same thing. So the input of the, let's say here, the output of the b variable is the input of the y coordinate, and the output of the second coordinate is the negative of the input. So the input was 2, the output is going to be negative 2. And then for 180-degree notation, you see that we didn't switch the coordinates. They're the same coordinates, but the x and y coordinate are both swapped. So how do you think we write that? Well, this time it's going to be negative x comma negative y. Okay, so here are the rules for translating by rotations about the origin for 90-degree clockwise, counterclockwise, and 180-degree rotations. You can also calculate like 60-degree rotations or 45-degree rotations or 37.9-degree rotations in either direction. That's much more complicated. Again, if you became a computer graphics programmer, that's the kind of information that that you're going to do. But I'm not going to ask you to do it in geometry this year. And in fact, the way that you do that isn't going to make any sense until we get some trig under our belt. So trigonometry comes later in the year. If anybody is interested after that point, let me know and I can explain to you how it would change for that. But this is all you need to know about rotations about the origin, is that they're just going to be about the origin and they're just going to be 90 degrees one way or the other, or 180 degrees for this class.